All right, back at the CAD program here. Got it all booted up, ready to rock and roll. I'll show you real quick some of the techniques I use to arrive at either how to lay out a hexagonal pattern or decide how much to down feed or in feed in my end mill into a round part to create the feature I want. One of the favorite numbers to remember is 1.732, and we're going to use that to create a hexagonal pattern here that's going to have 5-inch across the wrench flats, so to speak. So you're going to take 5 inches divided by that 1.732, and that's going to equal fairly close to 2.887, and we've laid that out as our center point here, and there's the 2.887 out there, and we've already taken the liberty of setting a divider at that dimension. So we then scribe ourselves a circle, and it's very handy and important to have a center line through this point, center, and out to this point. It doesn't really matter where it is, it just it's how you start constructing this this hexagonal shape. So if you're drawing this out on a piece of material, sometimes it's better to strike that line first. So then we take our divider and set the stationary leg at one of the outer points and scribe positions there and there. Sorry for the camera work. And stationary leg at the outer point there, and then scribe a position there and there. And now all we have to do is connect all 6 of these points together and we'll get a hexagonal shape. So there it is, we've connected our dots together, and there's our ruler through the center line and pretty darn near 5-inch. Of course, as with any layout, where exactly you put your lines, you know, inside, outside, does matter. So behave accordingly to the class of work that you're doing. So that 1.732 divide, the wrench size over 1.732 gives us this length from here to here, and that will then start to construct everything else. So we'll fill in a few more lines. So because it's a hexagonal shape, there's 6 points, which means that each one of these sort of triangles here is 60 degrees, and a 60-degree triangle is an equilateral triangle. So this leg, and this leg are all the same. So that's kind of handy, because we'll then know that the radius is the same as the length of one of those flats, and we can then divide this up further. So here we've divided one section of our hexagonal shape into a 60-degree section. We've then divided one of these 60-degree portions by half, so we have a 30-degree section there and a 30-degree section there, and that gives us a right triangle that we can start solving some of the geometric problems for. So knowing that this leg here is 2.887, we can then extrapolate from that, or calculate what this length will be, which will be half of our wrench flat, which of course is 5. So this is going to be very close to 2.5. But what that is, in fact, because we know the hypotenuse, it's the cosine of the angle of 30. Multiplying that will give us the adjacent side, which is this here. So then, knowing those two numbers, that gives us an excellent point that we can subtract that number from that number, and that'll give us this dimension right here, which happens to be 0.387. So had I have created a circle first that was let's see here, if I was building this out of round stock, I would have to start by turning a part that is just a little bit over 5 3/4 inches in diameter, and then set up, and then infeed 0.387 of an inch from that round feature and to create these flats. And then if I keep clocking the part around, I will be able to create exactly the wrench size I want quickly and easily without having to resort to too much trigonometry. Hopefully that makes some sort of sense.